this on. Just had the little email pop up. It's gone now. Okay. Emails in this series, I've been looking at the concept of mnemonics, and I'm using my Tabla Mnemonicos, which is a new little mind map I've drawn up on Miro. Just starting up the camera so you can see me. Here we go. Right. So this is a world space map. It says here, you are here. So this is the world view. It's represented by the letter M. A world space map only has one worldview, and it's located at M. Now, we also call M is actually it is a world view, so it's not, it's sort of like a camera. You want to imagine it like that. Now, there are a lot of parallels between this and a game engine. And since we're dealing with world spaces and world views and things like that, we can probably just imagine that this is a camera. So while you can move the camera around and do things with the camera, that's merely just moving the focus of M, the focus point. And we're talking about ideas here. So we're thinking about the idea of X. Now, the idea of X in our case is green. So that's an idea that represents the memeplex of green. Now, green can be a word, as in the English word green, inverted commas, Green. And in our particular worldview, world space, the X world space that we're looking at here, this is a very limited world space. It's a nice simple one. So we haven't introduced things like other languages and lots of different data types and all that kind of exotic stuff. So I don't have any exotic memetypal information being passed around through this graph. It's really, there's just some basic data types. So I'll go over the data types first. So we have some strings. So we have green here, and then we have this a type which encapsulates the data which would be used to indicate an RGB value. So that's tagged as RGB in the format you'll find it in an HTML file. RGB with a little bracket around the 0, 20, 255 and 0, little bits of data in there. So these are each integers, and they're coupled into an array, and that little array of three values then gives us the RGB value of green when used with various systems. And if we tell a person this is green, then they have an idea of what we're saying. So there are a number of different agents in this graph that influence M's concept of what green is. So the easiest way to think of X in relation to M is this line here. So this is a very, very important line, and this uses a block arrow like that, filled in black, and that is the connection between X and M, the direct connection between the idea of X, which we've said is green, but what is green here? So the idea of X is seen as M via this direct relation. And you can go into further detail to say how that works within the memeplex, which is located at M, which I'm calling a mnemonic series. So we looked at mnemonics in the previous video, and then the natural mnemonic series, and these arrows that are coming into M, which doesn't have any faces, because I feel that makes things a bit unclear. I think it's just the letter M is all I want there, because it's the container for everything. The M is the container in the worldview graph for our world viewer and all, the perspective that they have and all this kind of stuff. So as I mentioned, just think of this as sort of like a camera, but there's a lot behind that camera that's interpreting what's coming in through M. And the channels through which things come into M are these various channels. And like I said, in relation to from X to M, most functional and the most fundamental is this line, and it forms a network. So this is sort of like a bipolar relationship or a dipolar relationship. bidirectional relationship even between M and the concept of X. The concept of X has a more dominant role to play. It's more fundamental to the world viewer than their own view of what X is. So this is sort of like the realm of forms. So M knows that's what X is. But then there's also other things that M knows. So M knows some more details about what X is by looking through their own mnemonic series. So the mnemonic series that's located at M is this, which is built of the N1 mnemonic, which is essential. That is their fundamental belief, which is connected up to X here. So this connects to N1. And then there's a distance of N1 to, like an interval of N1 up to N2, and this is a black box in this case. We're not really interested in fleshing that out right now. So there's a mapping between M's N1 state, influenced from X, strongly influenced. This is then used. This then influences the shade N2 of the mnemonic that is located at the endpoint, and the shade N3 is another lesser shade because it's the third degree of separation, what we call a third state mnemonic. Not third state, excuse me. Third order mnemonic. First order being just the fundamental mnemonic, and then we have these two other N and N3, and that forms a loop within N. And I should say that I've actually made a mistake here with this particular arrowhead. So this arrowhead here is what's closing our loop. Yes, okay, I didn't see that before, so I need to change that. So just change this. Yep, there we go. Okay, so we need to change this arrow because it's closing a loop. That means that it's being sent from, and it's being sent from the host. So it's a cascade from the host, but it's a cascade from the host to the host. So this is where a cascade is a termination point. So you put this arrowhead at the end of a cascade. So we've got a cascade from X. So X is the fundamental cascade, which is this particular block arrow, and this little sort of divoted out little bit thinner arrow. This is the arrow that links from M back to itself. And I've realized now that I've also used the wrong arrowhead here, so I'll fix that. So this is now this here and this here. Okay, so this is two other actors within the scene, within the worldview. So they have their own worldviews. There we go. Okay, so back to this. Right, so this is our mnemonic series. So N3 is at a distance of N2 from N1, which is the end state. Is the mnemonic, the fundamental mnemonic in this conception, and then this entire loop, this circuit, this forms the same thing that this forms in our other two states of mind here that are hosted at other N points, so the N states. So these other N states that are hosted in these endpoints are S2 and S, and they represent, I've said in my key, two other sapiens in the graph. And we also have some other information traveling around. So we should have an X terminating to each of the theories of mind on the graph. Theories of mind. Each of the actors on the graph who have a theory of mind. So M has a theory of mind, S has a theory of mind, S2 has a theory of mind, and A doesn't. So in addition, we also need to be terminating to A. Now A is a closed loop. We'll talk about closed loops in a sec. Okay, so there is also present on our graph a law, and that law it could be a law from anything, physics, or just a truth essentially, but it has rules. So the most simple law is, of course, just a simple rule like green is green. which reinforces, of course, X, and is then therefore, just like any other law, terminates at the sapiens that believe in L, or know L, I think is probably a better way to put it, because this isn't really about belief, it's about what do you know. So, and also we have and then a continuation of that relationship to M, and that is done in what I call a parallel monodirectional mapping between S and M. And so S has tweeted perhaps that this is how you spell green, and that green is this color. So these are the two things that S has, that M has seen of S that M now knows. So that means that there are certain arrow forms here. So we're taking a, this is coming from S. So we can go over to our key, it's a cascade from a host. So M, S, S, and A are all hosts. And then there's a cascade, different cascade. This is a cascade from X to an M, M host or sapien S or an A. So basically just a host. So if your cascade's coming from X, then it's terminating with one of these block arrows. So we see that X is connected up via that terminating block arrow head to every single termination point on the graph. So these are all causing loops. So you have to imagine that basically with each loop that travels back up to our X, then these other ideas accordingly are then, they do then loop around, so to speak, and this is to enable temporality of the graph. But it's really just a hypothetical at this stage. But I imagine then controlling the line of t, the line of arrow of time in relation to this will revolve around how these ideas mix within X. But in any case, because we have an agreement, so I was talking about the law initially, because we have an agreement between S and S2 on this law. So there's the law is, in this case, I believe I chose that it would be RGB is 0, 255, and 0. That's our representation. So there's this variable coming down here, and S agrees that yes, that variable is true, and so that then terminates back to S, and then in addition to that, S2 is in agreement that that law is correct. So we see that S2 queries the law, and that S queries the law, and because they are both weakly linked through L to X, then X terminates back down to them, that law, and they know L to be true. In this case, M does not know L to be true. They just trust S that L is true. So L is true of X. So they are only receiving these weakly. They've received this weak indicator of green, which is coming from. Actually, no, hang on. I've got another wrong arrowhead. Sorry, that's supposed to be. Okay, so this arrowhead should be this little thinner one because it's a cascade from a host. So this cascade from S to M is monodirectional, which means that S is not aware of M in this graph, in this worldview graph. And whether S can be naive of M in other worldview graphs is probably more up to a situational type of perspective. But so we've got green, and we've got this light pattern here. We're assuming that I guess there's an optical sensor joining us here somehow, maybe an eye or something. And then green, we've got some kind of language interface and all sorts of complicated stuff going on. But essentially, that's agreed and known is the point of this graph. So our worldview knows these things that are terminating at us. And then we try to, I guess then by knowing these things, then there's an implication that we have a loop which continues from outside of ourselves back into ourselves, and also outside of ourselves back into the concept via our knowing of the concept through our understanding that's been linked up through these various different node termination points on us, then we then use our mnemonic series, our understanding of what those mnemonics constitute, based on our fundamental concept of the mnemonic, which in this case could be green, and then N2 could, for example, be influenced by the color green, which we've learnt from here, and it's mutated within us. And then when it's traveled a distance of N2 to, I haven't made that bi-directional, yeah, N2 to interface with our third order mnemonic here, which is sort of a black box, I guess, and is also influenced by some other something else that we know. Perhaps it's something that's coming from here or any other source, and this is cycling through N3 and producing the information that this color is weakly connected to our knowledge of what N2 is. Same thing here, except in this case, this particular circuit is connecting, because you can see the termination arrow, it's connecting the concept of X down to M. So it's about modularizing an idea into these mnemonic components, and then using the arrows to indicate how each of these mnemonics influence the other mnemonics in this series. It's about creating a hierarchy, if you will. So M knows of X whatever is terminated to X using that arrowhead. But M also knows of the mnemonic N3 whatever is terminated back to M from those mnemonics. So because we have a weak arrowhead here, these are a connection from M, who's querying the mnemonic, and along with the termination of their own ideas, which is a cascade from themselves back to themselves. They then understand what they've queried from the mnemonic. Okay, so it's a very long-winded way of trying to modularize an idea, but it's very, very useful when applying to art. Now I'll just pause it there, and I'll come back and I'll explain this closed loop.